Alright guys, you guys can hear me, right? Online? You guys can hear me online? Okay, excellent, great. Okay, good afternoon everybody. Alright. Okay, so I just posted the link on the Zoom chat, so you guys can put it up on the WhatsApp chat if you need to. And we'll start from here. Right, that covers this. Right, okay, excellent. Right, so today what we're looking at, we're going to move into VLANs, and we're going to extend our network with allowing the shadow network, and actually not just shadow network, we're going to have server networks in there as well. So we're going to grow beyond what it has with shadow network. So your assignment was just basically formalizing your research network, your shadow network into a research network, and allowing the VLANs to set up. This is the next step in terms of more details in VLANs, and that's where this comes in. And we'll go from there. Just to do some explanations, I'll bring up my packet tracer so you guys can open up the packet tracer and everything. Just see. Good. Right, so in the case when you look at the packet tracer, it's similar to your initial, all your labs before, as just this lab is being extended. So what we have additional, we have something called the server network is being added, and we have the accounts network. Of course our shadow network is there, but that should end up being renamed to a research network. That's where the assignment one kind of going that level. It's making your shadow network formalized. I would have spoken to you about that in the class on Thursday. I'll leave it up to you to figure out which ones is the broadcast, where's the collision domains, where the broadcast domains, and where's basically your VLANs, right? Now your VLAN is basically a broadcast domain, and then you have you look at your subnets. I would have done some explanations on well, I did it with one student this came out after class, where I showed where the broadcasts and where the broadcast domains are, and then where the packet will flow and stuff. That was from last week's lab. Demonstrate where the packet flow would have happened and where the interface would have known what's going on. But either way, let me continue. Right, so this is our network layout right now. Again, with all network designs, as you will see, we actually started to label our VLANs. So let me just put a label here. I showed it right. So you see the VLAN 81. This is the student network. Now, this kind of matching the student campus, not really the campus student network. Our student network, the ID number for VLANs is different from what we're seeing here, but that's fine. Right, again, you put your IP. So what's happening on top here, you'll see this top block here. Right, that top block, you realize it doesn't have client name interface. I just put that in there to demonstrate what is the network network ID, which is the IP, that V4 address in front, the mask, and then you have the IPv6 unicast. So that kind of more to help with the understand what the network is. Alright, compared to what the other guys down here. These are the IPPC IPs below. So 181.0 would be a network ID. You're not going to set an IP address with that. When you do subnetting, you are able to set IP addresses like this. Yeah, .0 at the end, but it just has to be a larger network, like a /22 or a /23. Right. Of course, we have our routers, route interface, and we'll show. Let me just pack this, and you can see that. Now let's do a network, so that's gig 00 and that's R1 here. Right, as you can see in the diagram. Shadow network, VLAN 111, just make it a little different. Right, again, you have the network ID above here. And then you have your device IPs below, and of course A little front here, you notice something here. R1 interface is gig 0/1.99. So we'll see what's going on with that one. Alright, when you look at the R1, right, so 0/1.99, and kind of going to figure out why this is happening, right? The main reason why that is being done is because we have to deal with how in the world we get in this server network to be routed through this router when we also have a shadow network. So what's happening here is that physically, when you look at this diagram, physically both the server on this side and the shadow network all going through one interface. Now with InterVLAN, when we did with the VLAN routing, so if you have looked at the slides and the rest of the slides, they were talked about InterVLAN routing. Right, that would have been where I skipped through it on Thursday, but if you guys read ahead, you would have seen that InterVLAN routing allows you to have multiple VLANs on one single router interface using something called router sub-interfaces. So we're going to start dealing with sub-interfaces in this lab, because that's the only way we can actually get a server network, in this case here, and more than one network, and shadow network going through one single interface on this router interface here. Now when we look on the other side and see, hey, what about this link on the other side? Just remember, we're not using this link to send this traffic. The server network has to go through the router in order to communicate with everybody else. So it has to go through this gig 01 interface. It may go through this link, but it goes through this link in order to communicate with the server network on the other side. So this is how you can this is how you end up spanning. This is an example of what, let's say, NatSci building a computer lab and Frank Stockfield student computer lab. This is an example of how they actually maybe configured on the network with all these switches with trunking, and they have set up a router to route traffic between those networks. Right, so that is how it is set up. Right, so this is moving on. So the next thing is VLAN numbers. Most cases range from VLAN 1 all the way up to about 1009. That's the regular VLANs, and you have extended VLANs goes to 2048. Normally we don't touch those extended VLANs, so more or less up to 1000 we deal with. In between is more for like specialized networks, where there's two VLANs, I think it was 1008, 9, or something like that is meant for specialized networks. You guys could read up on more about that. Right now, at the end of the day, you don't really need to have, this campus you have about 150 VLANs. Now, technically speaking, that's a lot of VLANs, yes, but you can actually grow more. But the thing about this is that if you segment it into even smaller, so let me come back here. If we have different, let's say multiple research networks, so our shadow network is one size, but let's say we have another shadow network for different projects. Let's say the Science and Technology has a network for their researchers, but then they have another sub-research group, or Department of Physics has a different sub-research group, and they want to be on a different network, right? We will put them on a different VLAN. That's how we'll have to do it. Broadcast domain. Remember, once we build in a subnet, that subnet has to go into a broadcast domain, and then our broadcast domain is being bounded by the VLAN setup, right? So that's what will happen. So each subnet will essentially go to a separate VLAN. As opposed to what we did before. Remember, we had multiple subnets on one VLAN. We're going to move away from that, because you're going to end up having other devices can pick up traffic, which we don't want. So that's why we split up. Now, we'll come to a point if we have hundreds of networks, we could end up running out of, or up to like 999, let's say 999 VLANs, we'll run out of VLAN numbers. So what happens is that eventually you employ a routed kind of architecture. I wouldn't go too much in this explanation. When we go later on the group project, you'll see how routed architecture can allow you to have the same VLAN numbers, and that's the group project. You'll see it where the VLAN numbers are the same, but their subnets are different. And because the subnets are different, the routers are going to just route traffic between it. So you may think, hey, there's a VLAN 111 is one side network, there's another VLAN 111 on another side network, but it's two different VLAN numbers. Personally for me, if I'm doing that, I would start to do some ID codes to understand that that VLAN is maybe not attached to, or maybe it's a special code that all 111 VLANs are research, and then you have some descriptions based on that. But it depends on what you implement them. Right, so you have to have good design, or else you're going to confuse yourself. Where you have VLAN 111, let's say down in Stockdale versus a VLAN 111 in that side, but they're two different subnets, which will end up being two different broadcast domains. Right, just moving ahead. Right, so accounts network VLAN 11. Same thing as before, but look what happened here. I did some subnetting here. And I did that to demonstrate that, yes, we're going to deal with some /24s, which we know, and now we're going to still deal with some smaller networks. Now, to make life easy, I still use the name of the IP address. Let me just go back. So, well, other than the student network, the accounts network, we use that 196.11. Whatever it is to match it to VLAN 11. Just to help us out, but you don't have to stick with that. Your 11 can actually be a totally different subnet. Your third octet can actually have a different value, maybe 50, 100, or something like that. And not only that, you can have duplicates, because remember, this is a 192, which would be a much smaller network. So it starts with 64. So that would be maybe /128, 192, so that's a /26 or /26. Unfortunately, I did not put a /26 here, so let me just put that in here. Right? That's what it's supposed to be. Right, hold on. Just have a little maybe sizing. Alright, good. I hope this works. Right, VLAN 5 server network. Again, this is you can see it got 5, but it's also it's a different subnet as well, even smaller. It's a 224. So after the 192 and 224, this is more like a /27. Right. So when you're doing subnetting, and there's a whole workbook for you guys to do it, and that's going to come like in your lab exam will come with that, your multiple choice course of exam will come with those things, right? So you guys got to do your work and read up on that. Right, so you're subnetting, so I just give an example of how I subnetted a small network /27, which is 224. And I intentionally use the 32 as a starting IP block here. 1 to 31 is the actual valid range for a block, which is a /27 or 2.24 mask. And then I did the other range from 32. So I did this to intentionally show you that that's the size of the network. Network is 32 clients, 32 devices, minus the gateway and the broadcast network, the broadcast address. That's the size of that network. If you use the IP calculators, this is what you're going to get. And I did that so that if you're adding up and you want to create another network, you go to add 32 to that. So then the next network will start off from .64. And then if you want to go to another network after that, it will start off with, I think it will be 96. And you keep going on, you keep adding 32. All of those blocks will make up each of the separate /27 networks. The different subnets, right, which will be different broadcast domains, that's what you want. And then you're creating VLANs to help, well, contain them and stuff like that, right? So you have to understand what you're doing here. So once you start to do subnetting, each subnet should be going, its own broadcast domain, which should go into its own VLAN, right, a separate VLAN. So you're trying not to put two subnets onto one VLAN, because you'll see what happens when we did earlier, our shared network and our student network happening with traffic is seeing, with roadside seeing traffic, right? And if you put a Wireshark on a PC, it'll pick up the subnet. So that's why we separate. Now, some persons dedicated, let's say some projects, they actually, and that's it, some project researchers, and they say university network or even anywhere, the company, they get a network to work with a subnet. And what happens is that they have their normal routed IP address, but they decide to put their own private IP in there that's not routed, and they have a separate shadow network of their own. They build their own shadow network. And they do that, that's fine. It's only if you start to see some attacks happening, then you have to deal with that. The good thing is that it cannot route out, so it stays there, whatever compromise will stay within that network. So that's good, they can do that, that's fine, because they manage it, they control it. All right, you notice a few things. Again, gig 0/0.5 is also set up as the server network. sorry, the sub interface 0.5. Now, when we started configuring the sub interfaces, you will actually see the how much values the sub interface can be. Now, it can be different, any value, but I can match it up with the VLAN number and match up with the subnet because it makes it easy. It doesn't have to, but that's how it's set up. Right, VLAN 3, the management network. This is the switches and stuff. So the switches are on the management network, VLAN 3. And again, I use the sub interface number .3 would be matching up the VLAN 3. Right now, let me go to the next slide. I'll explain something here for you. So I'm going to call it black hole VLAN. And this case is VLAN 999 in this designation, right? For ports not on any VLAN, right? You place on VLAN 999. It's not routable and prone from any trunk port, right? Hence black hole. So that is more for our design. So when you guys going on and setting up your enterprise network and stuff, is this is what you'll want to do with ports that are not like say the ports on a switch are not being used by anything. You want to put it on a VLAN, and the best VLAN to put out is on a black hole VLAN 999, so that if you plug in anything and it's compromised, it's not going to go anywhere. It stays on that switch. It doesn't leave the switch, and they say proof from any trunk port, so it doesn't leave that switch. If you want to fix that, easy. You just change port to the correct VLAN and you're done, and the device gets where it goes. So when you're not using it, put it on black hole VLAN. It's not standard. I mean, the value VLAN 999 is not standard, the number itself. And another VLAN can be used. Some people like to use 99, right? So I'll just do an example. You could use 99, right? So Cisco sometimes use 99 as the example because it's smaller. 99 is like the top of the 1,000 range. Some caveats, not caveats, but just word of advice, try not to use a 99 as a valid network in your enterprise. Just try to get the standard networks. We have some networks that are VLAN 999, and they're just there as an outlier. And we try to format, because it becomes integrated in your campus or your enterprise, you can't remove it easily. It's a big project to remove our devices out of it. It means you have to create a VLAN and then start to move the VLANs out and set up routing for that VLAN, etc. That's what. So when you plan it, try not to go on this arbitrary set VLANs. Just plan on what the VLANs are. So you have a whole VLAN plan for your campus. You can check the Cisco article here to read more about the black hole VLAN. Yes, so Cisco does have an article about it, so it's not something I just make up. Even if I Google it, they will point back to this article too. Right, so now that out of the way, summarize, I'll go through this pretty fast, try to explain as much as I can. Different areas, if you have questions, just post up on a chat or lab here, just guys raise your hand and stuff like that, and you follow accordingly. So of course, rename your packet tracer, download rename. I'm going to save mine as play, so I do mine as play. You guys could use yours as version 1, whatever it is, but I just call it play. But I could put a date and time, but I wouldn't have done too much time. So do that, because anytime you're not so sure, you can always press save before you do something that dangerous, such as going to simulation mode and crash it. If you crash it, you lose the information that you can save. Right, so that's the reason I would recommend you do that, especially for your lab exam. Because for your lab exam, I need you to upload your packet tracer file. And normally start with it, and I'll give you the directions. Put your stuff, student ID at the end of it, so you keep saving that. Up to you to do different version numbers. That's up to you. Right, so main steps, we're going to identify the VLANs, configure switches, ping PCs, switch 11, 12, 21. So we're just configuring and we're just pinging devices along the way. And we're checking the MAC address tables. So we haven't, we're going to set, what is happening is that we identify VLANs. When we say configure, what do we mean by is configure VLAN? We're configuring VLANs on these devices. And this is the main thing. This is the steps that you're going to use in your assignment. Right? Again, like I said, this lab was out a while, so you guys could check the commands. Right, so we identify the VLANs you see here. Right, right, we then identify the VLANs and then you configure the switches. Right, we already did the VLAN identification. Let me just open up a PDF of this thing so I could always bring this up much easier. Yes, I told him to put Sumatra PDF reader. Right. I'm putting a PDF reader. Why? Because we're looking to identify the VLANs. I'm doing this so that I have this table that I refer to. So as I go along the slides, I have a table I can just tab back and I get, hey, this is my data here, right? So that saves me a lot of time. Right. Identify VLANs and where to configure. Right, this is on switch 11. So what we're looking at? We're looking at the ports. So remember we have to configure VLANs on the ports and where we're going to deal with the trunk port. So again, build your table out like this. So when you're, I'm not too much asking for that in the assignment, but this would be something that you should do. I think the assignment, I'll check and see if the assignment is asking for it. If it is, then you guys have to do something like this. So you're basically putting out the switch, all the ports, and you're doing port ranges. So this example here is FA0/1-2. So it gives you a range of the ports, and then it's telling you what VLAN is going to be set at, the name of the VLAN, and the network. Now, ideally you don't need to do, you don't have to in when you design, but ideally you should map it to your network. Why? Because if you have a VLAN, you have a name, all that fancy stuff, but you don't know what network it is. It could be a different VLAN, same VLAN 81 somewhere else on the campus, a different network. That could happen. When I'm doing a big project upgrade for the campus, we didn't have a proper document mapping out your network to your VLAN. And that became a problem because now we need to say, hey, what network, what VLAN tagging has to be done on this network, or what network it belongs to here. So because of that, they didn't have that much of a documentation. So I have to end up documenting. So I have to go back to the system core, look at all the routable VLANs that was on the core. Once I find, then I can match that to a VLAN, match that as VLAN, and match that VLAN to a subnet, and then I work from there because the subnets will have their slash stuff. So it was a little bit of work, but at least it got documented. So now we have most of the information, at least matching back. So when you design, do this, makes it easier. So when you're going to configure a switch, easy. I could give an engineer this and say, here, take this switch, take this sheet, take it and configure my switch for me. When they're finished, they're supposed to be able to know that most of these things are to be done what it is. So if they understand Blackwell VLANs, must understand what that means. If they don't, they have to give them material to read up on it. Operating switch 12, the trunk, there's nothing saying anything with pruning, no pruning. So you just have to do a simple trunk and you're good. Right, so once they do this, they're supposed to be able to configure it properly. Right, switch 12, identify VLANs and where to configure for switch 12. So SW12, let me go back to switch 12 diagram. Right, so you can see 11 configured. Now we have ranges, so you'll notice that these two PCs were already there. We know what it's supposed to be doing. This guy, FA0, is PC25, but he's on port 3, I think. And he's going to be different VLAN, and then you have your trunk port. Everybody else will be Blackwell, right? Switch 12 now. Come back to switch 12. Let me actually go to my PDF, make it so much easier. Right. So switch 12, ports 1 to 12, VLAN 81, if you look at it, that's ports FA0. Well, sorry. Yeah, right. FA01 to FA02, that's these two guys. So as these two PCs belong to 81 VLAN. Port 3 belongs to accounts network, so that's a different VLAN. 10, port 10. Where's port 10? Trunk, it's same trunk in this diagram. Let's see if it's that. It could be. I will tell it a trunk. Move the mouse over. Right, trunk to where? No idea. Right, there it is. It's a trunk port. FA10. Now, this diagram didn't have all the labels, but because it's going to get too cluttered. So you guys, if you want to continue. So there is a port 10.
I was able to tell it was trunk from the time.
How you can tell?
Yeah.
No, I had to move mouse over each port link and see what's popping up. In GN, at least in packet tracer. If you don't label the diagram, you don't have to move your mouse over each of these links, these green links or the cable itself, and you'll see the actual labels pop up. Right now, I did see how it disappear after a while. That's why I ended up putting labels on it so that it wouldn't have to disappear. But I didn't label everything, so you have to do some discovery. So this is port 10. So when you look for port 10, look around, and we found out, hey, port 10 port 10 is this. You have to self Y. Twice it's a trunk port because it's going to have some interfaces being set up on this router, and we'll start dealing with that, and we'll see why it has to be trunk. Right. Next, port 23. It's also a trunk. It's a downlink. So you can see a few things. Your description name, or your description in VLAN, or your name of the VLAN, will have the reasons why. Uplink to R1, downlink to switch to team. So you put this into your name. So when you finish and you tell this guy configure, whoever's the other engineer configure, they're gonna put this and put these as descriptions. So this should have been name or maybe description / description when you make any configuration. When you configure these ports now, you'll want to put port description as another entry point here. So when you do that, it's documentation is the main thing. You can give this to somebody and then they can configure, right? You don't have to tell them, hey, these are the commands, well, what's the commands to do this or that. They don't have to ask you. The good thing about this is that I can take this design and give it to somebody like using Huawei equipment and tell them to do the same thing. Most of this terminology is the same in Huawei in terms of trunk port, VLANs. Those two are at least the same. So you can give this to a Huawei engineer and they could do the same thing on their equipment. You give this to another brand, Brocade, all these guys, same thing. You can even go GUI, graphic user interface, and say, well, it's all different. Depends on the technology. If it's SDN, you're going to move away from this. So this is not SDNs per se, but you'll have to plan this to what SDN is supposed to be. Normally these will go to port groups. You create port groups or roles, and then you assign a role to a port. And that is how it will work. So it's a little different. So SDNs cannot take it up a next notch. But for CLI stuff, this is what this will do. All right, so switch 12 has all these things. Anything else? There's a range here, will be Blackwell VLAN. Switch 21, same thing. So look what we're identifying all these switches. So this is part of the planning process. So you identify all the switches and what it is it's supposed to be done. And you ask, well, what's going to be configured? And you have to sit down with these people, whoever the persons who are using it, the end users, and ask them, okay, what it is you want here. Normally the LAN administrators will be the one to collect the information from the end users, and then they pass it on to the engineers. Engineers will then use that information and build out their tables. LAN admins don't do this really, the engineers will do this. Right? If a LAN engineer telling the LAN admin to do it, tell him to do his job. Right? Fill out the table, please. Identify VLANs and where to configure this again. Switch 22. So we kind of covered all switches here, 21, 22, and this covers all the switches now. So if we move on, all right, 22, switch 13, well, we'll just skip that, go back. And now we're going to configure VLANs based on device. So we're going to each device and we're going to go. So now we're into the real CLI. Configure, switch 11, create VLANs. So now we're really into it. So I'm just going to click. It's going to pop up on the other screen. That's fine. CLI. So I'm just doing this just to get these steps to do. Right? So you know something here a little different happening here, right? Right. Enable. Okay, so if some people, especially in lab exams, if you're getting something like this, they type enable and it's time to do IP domain lookup. Control Shift and 6. Alright, I tell you that a few times. Hope you guys write that down in your notes. Control Shift 6 is to come out of the break out of this lookup. Do not come and ask me that in your lab exam. I might reserve the right to mark it down by 1 mark. Right, you're going to learn this. I showed you. I already told you twice. This is the second time. Please write that down. Alright, so that's fine. So good. Right, let's do a show quick MAC address table. We're not going to details on who these guys are. We realize it's gig 01 on this switch. That means it's picking up, and we already know based on design that all the gig ports are uplink ports to another switch. So therefore this is loading device with another switch. That's okay. Right, configure terminal. Great. So now we're going to start. So type VLAN. Well, we could do VLAN 81. Right. So it's automatically creates the VLAN. Now this is the interesting thing. You have things called VLAN VTP VLAN trumping protocol, and then you have I think you have VLAN, switch learning VLAN. So you have transparent mode and all these things with VLANs. But at the end of the day, you may have to still end up going on the switch and creating the VLAN. So it's only STN, so we'll do it automatic, and that's through like code scripts and stuff like that. Right, so VLAN 81. Now, I'll just digress a bit. I'll do something called show VLAN. Do show VLAN. Alright, so this is the next thing. If you guys had a configure terminal prompt, what you could do is type do in front to get the show command to work. So it's just a do show. Right? You scroll up. You see the VLAN 0081. It automatically created a name for this VLAN. Alright, let me resize this one. Get a better. Might end up moving it back and forth. Right. So it's already created a name. So it's a name here, VLAN 081. If you notice here, you see the other ports are in the default VLAN. I mentioned about something about default VLAN and stuff like that, and I said move it to the Blackwell network. The default VLAN or native VLAN in this case is 1. If there's no what you call let's say you plug it's more from trunk ports. If this what you call untagged traffic is connected, is on a switch, you plug into a trunk port and it's untagged traffic, it goes to the default VLAN. Right, which means that if any device is on that default VLAN, you can take a trunk port and plug in a PC and it'll actually get access to that default network. If you put management devices or network management and servers on that default VLAN, guess what? I can take a PC now, disconnect from an uplink trunk port, plug it into that trunk port, and get access to whatever management servers or management network that is, right? With a PC, because that's default, untagged. So next rule here, do not put management or anything on your default VLAN. If you want that default VLAN should end up being either a black hole or you don't or you leave nothing, don't put anything on that. And normally you do a security sweep and identify devices and then tell them to move it off that default VLAN. That means if you pick up something, it's either somebody is putting something on a trunk port, which is not supposed to happen. I mean, it disconnected uplink, it means services down somewhere else, or somebody else is setting a default VLAN on a port and actually using that network. So that's why you don't configure. That's why you see my management network, switch managers and VLAN tree, different network altogether. Right, so we're going ahead. We're going to start with name student. So we're in this VLAN configuration mode, we type name student. Right, so this is the we name the VLAN. I could just do name question mark and it'll actually be an ASCII word for the VLAN. There's a limited amount of characters for the name, so you can't do much. Maybe I think about 20 something characters. So don't try not to do too much. Eventually, because there's a limited amount of words, the characters for this name, you'll have to end up going cryptic more information, right? If I do a do show again, you look up here, there it goes, VLAN 0081 has changed to student, which is fine. Now what I sometimes do, for me, I could call it, I sometimes do name 0081-student. Now sometimes I do that, or sometimes I rename it and put student and then dash VLAN 081. Now I might do student, and I do that because I want to say, why? Because when I do a show VLAN, everything is kind of ordered, because when I want to show VLAN, I get the name of the VLAN immediately, so I know what VLAN it belongs to. If I do, if there's something filtering out, I don't have a number, this is supposed to help identify the VLAN, but you don't have to. I'm going with what I'm doing here, that's what we're doing. Your design and what you're doing could be different. Right, so now we're going into VLAN 111, name research. Now you'll notice some comment here. This changed from shadow to research. So somebody asked about, hey, why is that I'm seeing shadow in the assignment, and now I'm seeing a next network as research. So shadow, yes, that exists, but what happening is that network is now being moved across to research. So that's why the assignment had it. There's a transition. Right, next one, VLAN 999, name black hole. Right, could do you show VLAN, and we get all of VLANs here. Research, black hole, and stuff that is created. You notice, look at that, 1002, FTDI, and token ring, and all these guys are reserved, right? So that's why you go up to 1,000. And we wouldn't use 1,000, leave 999. So let that be a last VLAN, that's why we create. And it's easy to see that as a black hole VLAN. Anything before that should be valid. This one should be, everything should be, not routing supposed to happen this one. Right. Right, exit. Right, assign VLAN to switch ports. Of course, we want to know, well, what we're going to do, how we're going to do this. Right? If you, as an engineer who knows what to do, you give her the document here, right? So from this, you can actually, this document, I can use this document and make my changes. So let's say I come back here, not to confuse the whole screen. Let's come up here, not to confuse the screen. Right, so we can do, so what we're going to do, we can actually going to do, right, well, we do exit, so let me just do an exit here. Come back to the console. Enable, just in case, show VLAN. VLANs are here, that's what you want to do, and we're going to assign the ports to these VLANs, right? Right, so some things you're going to see some interface range, switch ports to access VLAN 1, switch port mode access. This is removing something called a dynamic trunking protocol, DTP. Right? Shutdown, no shutdown, don't have to, but do it just to clear the MAC addresses and reset the interfaces. And then you bring it back up, show VLAN, you'll see it, right? So I can come back here, I can literally go back to this, leave a note to see the commands. Configure terminal, interface range. And look, Cisco's doing all the work for me here. Interface range. I'm seeing FR set at 0, right, slash. I'll do a question mark to see what it is. I'm going to start with 1. Right, now this doesn't tell me a dash, so you can see there's a dot. But we're not doing that, we're going to do a dash here. So this is where you kind of have to, right, so you have to play around with the question mark to see how the help works, right? So again, for CCIE exams at the highest level, they will give you the equipment to work on. The equipment has all the help information in it, right? You don't check the books, you already know what you need to do. You just have, for the actual commands, use this. Even for the Cisco exams, I end up, I use the question mark a lot in the console because I may not memorize the whole command to type, but I know what I need to go to. Alright, so look at this. I even know to go through this. I know this is what I want in my design, and that's why I bring up the PDF here. Know what I want in my design, and I end up doing this. Fasten at 0. So you see a hyphen. So I'm doing a hyphen. I'm doing a space. It's going to be a number here. Last port number in the range. Right. You could also do another Ethernet stuff, but we're going to do this range. So we're going to do a range to 2 space. Now in this case, there's some additional stuff you can do. You can add a command and add another set of interfaces. You can go really complicated in the ranges. It's good for when you're doing like bulk configuration on equipment. Out of the box, you can just set this up. Right. You do different ranges, especially with gigabit ports. Right, so we select the range. Now you know just configure range. If you don't do it right, you might throw an error. Let's see how I can get an error here. I took enough spaces here to see if it give me an error, right? Let me put a comma. Right, so a comma get me an error. So look, I can actually go into interface range with 1, 0, 1, no spaces, dash 2. But if it's allowing you to do spaces, get your range, you do that. Right, so next step, switch port mode access. We're forcing this into forcing into an access port. So there are two types of ports. You have access port, trunk port. In most cases, switches out of the box can automatically negotiate which port it goes into. You want to take that as basically dynamic trunking protocol. We do want to take out dynamic trunking protocol. Why? Because we don't want an access port to become a trunk port. Why? Because an access port becoming a trunk port means that all the tag traffic that is coming across the other networks can be seen across that port. And technically, you can what you call port mirrored, make it a mirrored port, and then start to do packet sniffing and find out any net coming that trunk that's tagged. You can pick that up too, right? So that's what happens. That's the problem with trunk ports. So that's why you try not to do that. Not only that, if we make that dynamic, let's say a trunk is set up and it's working, all of a sudden the switch is restarted, and they try to negotiate the dynamic trunking protocol, and it's taken a while. It might stay in access port mode, and you might have a trunk setting up. So forcing the trunk mode access or trunk keeps reduces how much of the what we call negotiation time. So switch port mode access, and then switch port SWI, come on, switch port access, right? You could do a question mark after switch port and see what kind of ranges stuff you could do. Right, we did mode access and then access. We could take out the non-negotiable stuff. We will do port security at some point. We're not doing priority. We're not doing priority. We're going to do trunk just now. We might do voice later on. I'm not so sure. Right, switch port access. So you see access is what you want. So it's a switch port change to access. Then we're going to do access, and then we're going to set VLAN. After question mark VLAN, and you're going to do a VLAN number. So who's this? This is VLAN E1. Anything after this? No. Enter priority change. Right, so let's see if the commands are right. Right, interface range. Right, so I end up doing access VLAN 81, and then I did switch port mode access. So I kind of flipped the order. In most cases, the order doesn't matter once you're doing them one after the other. Atomic statement, if you want to call it that. Make sure you execute. If you don't, and let's say you do switch port access VLAN 81, it might still be in the negotiation mode of the GTP, which you don't want. Right, so even if you're setting VLAN, it can go into a trunk. Right, so you're going to shut down the port. Now, shut down. One way to tell if it really works, you can see fast and 0, 1, and 2 went down. Right, I shut down. And no shutdown. This is just to reset the port, so then all the MAC address table cleared, it's on the right VLAN, and all these things happen, right? And you could do an end. This is to take you all the way back out to the privilege exec mode, and then you do a show VLAN. We did 81, right? So look what's happening here. Our ports are actually the port's actually configured now. It's moved across into this VLAN. Later on, you're going to see where you're going to have configures where it's showing looking for ports, and you're seeing some missing. So this is 0, 1. This is 1, 2, 3, 4, 5 to 10 of the gig 1. 1 and 2, right? Sometimes later on, you'll notice you did a show VLAN, and you see some of them missing from this table. It's not even in any of the VLANs down below. When we reach there, we'll explain why, or explain where you will see that happen. So we did show VLAN, we're good. Right. So the next step, obviously, we go on the next step. So I did it already, I did explanation, so I'm just running through faster now to get all these ports configured onto the right VLANs. Right, you notice I only did one row. All those commands just to one row. Now we're going to do the next one. Same switch. Right. Configure terminal. Interface. Is it a range? No. No range there. 0/3. Right. I'm going to do switch port access VLAN 111. And go back switch port. Oh, no trunk, I ain't gonna trunk. It's such trouble, right? The one that's support mode access. You can experiment and try what happens when you do trunk mode access, right? And we just do a shutdown. No shutdown. And it's good because if you do the port assign, like you did the port assign if you went first, then you change your access, a shutdown and no shut will kind of reset that port, and then whatever is set there will start up. You can put that configuration on. Right, that's cool. So we do N, show VN. Search network FA3, right? So we moved across from on top to this one. So we're getting it. Right, so now we're looking at the VLAN 999, Blackwell VLAN. So you notice some ranges happening here, right? Comma and gig and things. So this is where the comma and the comma is coming because you're going to use different interfaces. Right? We're still on this. We haven't touched the trunk yet. We're doing that just now. But we're just moving everybody into the Blackwell. Rest everybody in Blackwell, right? Easy stuff. Again. Configure terminal. Right. Interface range. So I'm not even looking at. You can look at that. So we're going to do FA. Fast Ethernet 0 question mark slashes command question mark nothing, so we're going to do a speed. A number comes after that, so let's do it. Right. If you do a space question mark, it's not going to be valid, right? So we start at 0/4. We do a dot, but we're not looking at it. We're doing a space question mark hyphen space question mark and another value 24. So we're going to do range 24 question mark of that. Let's do that. Let's go. Right, we do a comma. Right, so for the range looking good. Space question mark. Now we're doing gigabit. Alright, just going to show you how you can build this out, right? I'm not memorizing everything here. I'm doing it from what I know. So we're doing gigabit, space question mark, and it's just 0/2. Luckily it's easy for us. Now if we want to do a gigabit range, we can do the same thing here, right? Gigabit there, we can do a 0 space, right? Look at that, hyphen, and then you could do 2. So it's 0/012, right? So I can do that whole thing with gigabit. Right, but I'm not doing that, so I'm going to just do it 2. Right? Anything else after that? No. So we're going to enter. If any errors, it'll throw an error. If not, we're good here. Alright, so I'm just doing this to give an example of how it's working. Right. Switch port access VLAN 999. Alright. Switch port mode access. Right, we do a shut. Right. Look at those ranges. We did a nice range. Look how much ports went down and up. Even gigabit 02, which is what we want, right? We'll shut, bring them back up. Done, and show VLAN. Right. So all this guys all the way down going on to the Blackwell VLAN, so we're good. Gig 01 is now in the default VLAN. He's supposed to be trapped, right? So we're going to deal with him just now. Everybody else is accounted for, which is good. Every port is accounted for. Right, next step, we're going to set up the trunk port for the switch. So what I'm doing basically is I'm actually just doing most of my configuration on the switch, and I'm moving on to the next one. So interface gig 01 and simple mode, right? There we go. Right, so we go back to 12, 11, sorry. Right, so look at this. All those commands you type was literally all condensed in this table here, in what we just did. So you can see how easy it is at table 1 to document it well. Continue permission need to go on the port. Right, so let's continue configure terminal. Interface, no range this time. Gigabit 01. Switchboard mode trunk. Right, so when you do trunk, it did its own reset. It took put it on board back, but you could still do it afterwards. Right, switch ports, and you have non-negotiate, right? Right, that's what we did here. So always be trunk. Right, do a shut. No shut. Right, data up. And show VLAN. Right. So it's gig 01, so let's see where it belongs. It used to be default. So where it has gone to. So I notice there's no trunk port here. And if you look at it, gig 01 is not labeled, it's here. Nowhere else. Alright, so you want to know where your port has disappeared to. Now, plenty few times you're configuring, you're checking this, and you're looking and say, hey, yeah, everything good. But you really need to go back to your table and map it back out, right? Because if I go back to this table, right, you can actually type out all the what it is you're planning it out, and then see what it is mapped back to. And you know that gig 01 is a trunk, so you know, hey, it's not supposed to be here. Right, so we show the VLAN. Right, so the next thing is, okay, great. If we do a show VLAN and then up there, so how can you tell it's a trunk port? So this is what we're doing. We're going to do show interfaces trunk. Come back here. So right, show interfaces trunk. Right, so what's happening here? It's telling all the trunk ports on the switch. Gig 01 is the only one here. And then it's giving you a range of VLANs along the trunk. You know, it's 1 to 1005. That means any PC, that means that anything that's on that this trunk port has all your VLANs. So if this VLANs is being broadcasted, this switch will broadcast on the trunk. But if you have a PC connected, the switch will broadcast into that PC. And the PC, if it has Wireshark, will pick up all those trunk broadcasts. So that's why all the VLAN broadcasts, right? So that's why with a trunk port, it's more like considered hitting not G-Jack, but hit and go. Yeah, actually, once you get a trunk port, a lot of traffic will come out of there. Even if it's not intended for the PCs there, it may actually be going to another switch down the line to another PC. So that's in terms of data, and those who those are doing analysis of network and capturing data, and physically in the network, that's what's happening. Now, of course, you have to be physically in the network for most things on connected devices, right? Right. So the next two others is right, VLAN allowed active management domain, and then you have VLAN span tree forward and state and not prune. So we'll talk about span tree later on in terms of loops, but we're going to start to prune some VLANs here. Remember the black hole VLAN is supposed to be seen here, because that means this black hole VLAN is going to be seen by another switch, and traffic from one will flow to the other one, which we don't want. Right, so switch port trunk allowed VLAN, and you're going to remove 999. Global config. Oh, sorry, I just select the interface. Right, switch port trunk, allowed VLAN. You do a question mark, and you can see allowed. Right, so you can actually do some commands here. Allow, you can add VLANs in the current list. You could add all VLANs. You can add all except, and then you put no VLANs, and then you remove. Right, so this is the thing. When it depends on your network design, you may end up having to remove a VLAN on a port or add one. Sometimes removing might be easier than adding. Sometimes when you add, you might add only one VLAN and it removes all the others. So if you do this, right, switch port trunk allowed VLAN, and you put 99 or 999 for instance, it's going to add that VLAN and then remove the rest. Right, so you have the switch port trunk allowed VLAN, but we're going to have continue the command. So you're going to space, and you can see the command remove. I'm doing a space question mark, and then we just have a VLAN number. So in this case, 999. You notice going up to 1494, right? So that's the from after 1000, that's the extended VLANs. So don't really deal much with those. We leave them as it is. And if you decide to go extend VLANs, then that means your design is not as robust as you think it is in terms of expansion. Show interface is trunk, so let's go back here. If I could do an end, I did an end, yeah. Right. The show interfaces, you can see VLANs allowed in the trunk, 1 to 998, comma, and then there's another range. Instead of before it had a nice range. Okay, VLANs allowed in the active management domain, you see 999 is not there. And VLANs in span entry forward are not pruned, which is not there as well, so which is great. So now only anything put into that VLAN is not going to, even a trunk port is not going to be broadcasted out. It stays on that switch. So it really is on that switch, and your traffic not going to flow. This is what you want to do for your network. You want to really secure this. Right, so we're done, and then we can do a show dynamic trunking protocol. Right, 0 interfaces using dynamic trunking. If we had it set up, we would have seen, where we took off the we put non-negotiate, right? So if you had removed that or put no non-negotiate, you would have interfaces using DP, would have been 1. All right, we're done here. So now we're going to copy running to startup. Right, all right, WR, right configuration. Doesn't matter in the lab exam, you guys use whatever means to save. And this is a marking for this. If you don't do your running config, but you just click and save on packet tracer, you wouldn't get any marks for that. You might get marks for the commands, but not for your running config being saved. So you might lose much marks, but you'll lose some if you don't use don't save. Right, so this is I'm showing MAC address table clear. Nothing too much here. More looking at the VLANs, because you notice in the left hand side you're seeing VLAN 1. Now everything else is, before I think we had more MAC addresses in VLANs, but because we started trunk, put things in trunks, It's not propagated. So we're going to do a clear MAC address table, show MAC address table. I'll be empty for a bit. Right, check PCs. Can PCs ping one another? The marks is up. Oh, well, we now starting up. Maybe not. Well, let's find out. So it's PC 11, 12, 13, and 14. So let's see what's happening here. Let me save my packet tracer through one time. Right, your copy running config or WR write memory. It's different from clicking any packet tracer save. Remember that. This is saving it in the global packet tracer does it. A good example is emulators. Those who are playing emulators and stuff. You can actually save the game in the emulator itself. So you have quick save, quick load, and all these things for those games, right? But you can actually use the emulator device, the actual emulator device, to save the state of the emulation, and then you can actually restore state. And a lot of people actually use that to make their speed runs, make it like they're doing well. What they do, they actually play, save a state, play, and they think they reach good, then they end up restore the state. What they might not do is the video that they use to record it, they actually might cut the video, so they actually clip it and clip it and make it look like this. So that's how they make the speed run. And because it reload the state, the timer of whatever, depending on the game, will actually continue running like normal. So they clip it and they do it well. So it depends on the speed run. So if it's good speed runs, they will do it right. If not, they go use emulation and save the emulation state. So clicking packet tracer save button is clicking save in the emulation state, but doing this save command here, copy run start, is actually saving in the environment itself. Let the equipment do the work, let the game do the work. Right, so PC 11, we so fast. Yeah, we'll take a break after this. IP config. Alright, it has an IP address. 81.1. Okay, good, good. Thing 192.168.81.2. Right, we're pinging 81.2 from this PC, which is great. Ping 81.3. Should have done a ping PC before, but try to ping 81.3. And we're getting timeout. Then the ask well, where is 81.3? 81.3 is actually PC 13. He's on the other switch. We haven't touched that yet, but what's happening? We already started to do VLAN. So the packet is actually not going to leave the switch, and we're going to do. That's why I'm going to use packet tracer simulation mode, and we'll see what's going to happen. Right? Simulation mode. Oops. Show filters, edit filters. You want ICMP? Let's do now. Anybody here? No. Miscellaneous. Anything else you want? Not TCP or UDP. Really got it. Everything else we want, right? Cool. No, wrong one. PC. Right. So set that up. Right, so moving across the switch. What is this? Right, guess what? We never dealt with ARP before, but I actually allowed it in the packet tracer mode. And my simulation where I look at that, all F's frame, destination, all F's. This guy's trying to figure out who this PC is. MAC address table. Now the PC doesn't know, Twitch doesn't know, Switch is sending it out to everybody. You'll notice that this is I left the ARP request in so that you guys actually can see the broadcast happening, right? Hold on, let me just close this. Did we pick up? Look at that, he could have, I don't know why it didn't go there, but let's step through. Right, so get back up. Response here. This will be the first time out coming up there. Right? Right. There it is coming up. Right. First request timeout. This is loop packet here. Starts the next one. right? So first timeout, it didn't reach. If we go to the next step, this guy's doing a next what? Up here. Next up, going again, trying to figure it out. So this is a good example of you trying to ping somebody who's on your network, but a piece or an IP address that's supposed to be near a network, subnet, but the PCs doesn't have an IP configured, doesn't exist. This is what's going to happen. The switch is going to be, the broadcast is going to happen. So each time you do a ping IP, and I do a ping IP in a timeout because the device not there, it's forcing broadcast to go out, right? Telling the switch, hey, give me and do an up. So let's do this step through, right? Up there, it's not going to happen. What I find weird is that it's not sending up on 25. Oh yes, it's not, right? Because 25 is on a different VLAN now. So that's the next thing. Before, if this wasn't configured, all the broadcasts would have gone through all the connected ports. But because we connected a safe with this port 3 is on a different VLAN, and port PC11 is on VLAN 81, student VLAN, it's actually going to send only broadcasts out only on the ports that belong to that VLAN. Now, this gig 01 is not on that VLAN, but it's a trunk port. And we didn't prune 81. So 81 is a possible VLAN on this gig 1 that it will send out a broadcast to. So it did send out an ARP request through the trunk. So guess what? An ARP request can actually go through a trunk line, a trunk port, which means that an ARP happening in the computer labs in from that side will reach all the way down to the computer labs in France, Dr. or W Huggins, because they share the same VLAN going all the way down. An ARP request, right, as a layer 2. So that can happen from there all the way down to the there through the network. That's how it's set up, right? So it can happen because of the trunk. Alright, so let's come out of this, go back real time. So we get an ping timer, that's fine. If we try to ping the other IPs, we will be getting timeouts because once it hit this switch 12, anything on switch 12, we're going to have problems. We already passed, anything passing out of switch 11, we have not finished switch 11 configuration. Right, so that's where we are. We're going to get right, so we're going to get timeouts. So we're okay here, and we're going to get timeout, timeout, and timeout. Right, and we've done this. Right, we could do a show MAC address table and see what's happening here. Right, FA01, FA02, build it up, give 01, but we don't know it, but nothing else. But you notice a few things. I did this. Your VLAN number now is on your MAC address table. So you know what's happening. Your switch is learning MAC addresses, what I showed you before, but now it's pushing it on the VLAN it learned it from too. Right, it's doing all of that. Not just the interface it learned from, but the VLAN it's doing that as well. And when we start to do sub interfaces, you're going to see that you're going to have a single interface, multiple VLANs, a single interface, multiple MACs, right? But it'll learn that from multiple MACs. It might end up being a trunk port. We will see when we go along from there, right? So right now this is on VLAN 1. Gig 1, we'll fix that afterwards. Let me just see the next slide. Right, so switch 12, let's take a break here. 10-minute break, right? Right, we're going to resume at 1:20. At what? No, yeah, 1:22. Mute this, mute video, I'll leave that video up. Mute no OBS. Alright guys, and we're back. So my zoom is good. Alright, great. It looks good. Alright. Right, so we're going to continue configuring switch curve. I'm going to move a little faster because I did most of the explanations already, so this should be straightforward. Straight to the VLAN to a port. So I didn't create the VLANs yet, but actually I've created it before. Auto creates, but let me go back and let me do that, right? You only one, right? Oh, we did A1, right? Okay, we did A1. Right. Make sure the VLAN is okay. Matching up to our table. 81 is there, 11 is there, 5 is there, 999 is there. Now I'm seeing VLAN 111, but I am not seeing a purpose of 111 here. So quick question. Is IP 192.168.1.25 supposed to be which devices to ping the broadcast network? Get the mask, plug into the IP calculator and find out if that is valid IP or broadcast IP. And you'll get your answer. Also check the IP address listing, right? And the tables are up on the PDF, so check that out. No, I'll leave you guys to do that too. You guys have to figure that one out now. Right. So Research network is not listed on this table, but it's listed here in this command. So I'm doing the commands, you ask yourself why. I'm doing it up front. Why? I'll tell you why. So this is all deviation. What's happening? Yes, everything directly connected. Yes, we're going to put VLANs, but this is the thing. If we have traffic that has to pass through this switch, it'll have to have knowledge of that network. So what's happening is that I see that trunk port here, and I didn't label it, I didn't put it in, but on this trunk port there's a research network on the other side. You're supposed to put a VLAN that the switch knows about that VLAN. If you don't, if VLAN is pruned, the switch would not know about that VLAN, it wouldn't on target, or it wouldn't even take that traffic and pass it through. Right, so there's a chance it mightn't go through the trunk. It might or might not, it might have no knowledge of it. Let me show you. Because when you do show interface trunk, oh well, sorry. There's only one trunk. There's only no trunks yet. We're going to set that up just now. It may or may not allow that, but we'll see. Right, VLAN to switch ports, we were working on that. Right, where did he student? Right. Right, switch 12, right. 03. Access. Yeah, 11. We already switched. We did mode access and everything, right? You shut. And VLAN. Alright, so we got 3 is, where is VLAN? 11 is done, accounts, there's only one port, so then we did these two. So we're going ahead. Right, so this one is interface just now. Right, the number on the slide, assign VLAN to switch ports 3, that's just the running number. It's not VLAN 3 or switch port 3. Right. Remote access. Shut. This is going to show VLAN verified at your ports configured. So silver is now configured. 4, that's good. Number 4 now, we're doing the black hole VLAN. Range 0/4-9, comma, right, 0/11-22. Right, nothing else after that, right? So we just space. I have it there, but I could space it out. The space out should be valid as well. Right now, we don't know what interface range this is, right? So a nice thing is, how can we tell which is the right interface? This is what you can do. You can do something easy, something called description. right? And this is the black hole. You can actually put a description of ports. So if you don't know what ports are arranged, do a description on it. Enter, and what you could do a do show interface description. Oh no, sorry. Status, yeah, there it is. Do show interface status will actually show you the name of the what's the description of the interface, and the range that you select, and you did the description. This is how you're going to tell. So one way of telling by running to put a description, so you set something on it. So we're looking at port range 4 to 9, which is what we want here. 11 to 22. So look at that, 11 to 22, and that's it, nothing else. So we label it to what we want, and you could do description, a lot of stuff, and then we're on the right track. So we can leave this. This is good. All right. Switchboard mode, access, switchboard, access, VLAN 99, right, shut, no shut, and we don't end. Show VLAN. Right, all these guys move to black hole, which is what we want. Nothing on the research yet, not on this switch. Set up trunk ports, and look at that, we have a few trunk ports here, 1, 2, 3, 4. So we do an interface range here first, right?
Sir,
Alright, yes.
you point to the black hole VLAN, it's just take ports down with the disabled ports.
Yeah, if ports that are not in use,
You assign them to the black hole VLAN.
yeah, that they're not using. What I mean is not used is that they're actually not patched or connected to APC or device in the back end, because they set up a switch, you have a set of ports that they may patch to a patch panel, but the patch panel has nothing connected to it. Put those into black hole, or for that matter, they're not patched to a patch panel, they're just empty on the switch. Put that as black hole. Why? Because if somebody has access to the cabinet, they could just go in and plug in, and that's it. But if it patched to a patch panel, means it going to a drop somewhere in the network. Means that there's going to have a PC somewhere there, or not, based on the design. Okay, a good example. Our staff, the DCIT's conference room, seminar room, right? They have some ports in the wall that are on the staff network. Because it's a restricted room, we could afford to do that. That means somebody could plug in a PC in there and get to the staff network because no one has a PC. Now, I could put the other ports that go to that switch on a black hole VLAN. But the thing about it is that putting black hole VLAN may not help us at all, because if we need that port now, then I have to go back and configure that switch. Now, if it's an engineer has to do that, we have to take that information. You want to do a conference today versus now from the morning we got notice to do something in the evening. The time process, our SLAs are not good in terms of turnaround time. SLAs are like 2 to 4 hours, 2 to 4 hours, right? That's typical SLA turnaround. You don't get it in 5-10 minutes, right? So because of that, we can't put in a request, which could take 2 to 24 hours or more to get that configured. So because it's already patched and the drop is there, it's more the IT people to make sure that that is not, nobody's using that for any other information except for staff. So it may be open. It might not be used on the switch, but it will be marked as a staff port, but it will be patched to a valid drop. If it was not patched to a valid drop and just a port on the switch not patched anything, you put that in a black hole. So into anybody trying to come into the switch and plug in and patch, you're not supposed to do that because it's supposed to be patching something valid. So that's where the black hole is. And once you do that, traffic is going to stay localized on that switch. And once you see black hole, you can end up you put these ports in a shutdown state and leave it off, right? But most cases, put in the black hole, leave it in black hole. You can leave it enabled. So if somebody plug in, then again IP or internet, you could then the port working. And not to say that the port is a problem, the link is the problem. You want to make sure your layer 1 is working good, right? That's why you leave it enabled, and then you put in black hole and you do your test from there to see why it's not working in the broadcast and so forth. Right? Okay, 12. What we did? We're going to do the Right. Right. We're gonna do our trunk ports, right? 0/1 comma. Now, if you want, you can actually put a range, and you could just put every single port one after the other. You can do that too, right? But defeat the purpose of the range, especially with consecutive numbers. But in this case, it's different interfaces. Right, ideally it's supposed to work, and we can actually, if you're not so sure what it is, what we could do is change the description and say trunk, right? And then you could do a do show status, and there it is. Who is our trunk ports? 10. There it is. 23, 01, and 02. So what we just labeled description is meeting up what we range set, right? So now we know how to tell we are selecting the right range, and it didn't error out anything like that, right? Switch port mode trunk, it's going to do a interface resets. Switch port non-negotiate, so it will stay in trunk. I wouldn't try to go into access mode or whatever. And show VLAN. Alright, so you'll notice those ports, gig and stuff is not in the list anymore, even the default is gone. Because the trunk, so when you do show interface, show VLAN, once you start to hit show VLAN, do a show interface trunk, right? Once you start doing show VLAN, do show interface trunk. Now this is the next thing. Right, okay, VLAN's on a trunk, great. So take a good here, good here, good. Right, identify VLANs where to configure switch 21. Okay, we're moving on to switch 21, so we're going ahead, moving ahead. We're not spending too much time thinking and all these things. You know this very weak, right? So we're going ahead, we're going along, and we're going to finish this off. Where are we? 9, nice, nice. Faster we go, faster we go. Right, we did trunks, we did these guys already. Oh no. Right, we did the trunk just now. What we did was supposed to do, we're supposed to remove the VLAN 99, so we didn't do that yet, right? So let's go back to switch 12. Do a T. Alright, what we did, we had to do an interface range, right? Go back to interface. Luckily, cached, right? What I like about the command history. So I'll type it all over. Allowed VLAN. Remove. And we're going to move 999 from this. That's right. Right. E and D. I'm going to write this thing out, right? Come on. Show interfaces. Trump. Right, so you see the range here. VLANs is allowed in trunk, and we missed that one out, right? And then we do show UTP, no UTP. And I'm just going to write, right. Okay, now let's move on to 21. Alright, we're skipping it. We're going to play PCs, no, no, about that. Oh, alright, so way down here. Sorry. Yeah, now I skipped ahead the ping PCs, right? We're going straight ahead. I'll leave that you guys to ping PCs and stuff. So we have the 21. Right, so we're going to create VLANs 11.5 and 11.5 and 999. Right, we check it on 21, 1-on-1, 999 is there. Hold on, where's research? Hold on, we're missing somebody. Right, so 5 is there in the config, but the table doesn't show it. Right, so the reason I did those commands is because, again, it has to be aware of this server network coming across. Right, so this port has to be aware. If it's not aware, it might pass that traffic across. So that's why we end up configuring, and that's why the commands are there, right? 11.5.999. Terminal VLAN name, research VLAN 5 server 999 in Blackpool, right? Right, assign the VLAN to the switch ports. Interface range. Go on, do this. Get this done right there. (0/1-2). Right. Support mode access. Yeah, you know, normally I type it out. I start the set the access mode first, force it at the end, then I have the access VLAN set up. I think this command, I don't know why the commands I did it the wrong way, but that's okay. I think it's more for these steps: assign the VLAN, then change the access, as opposed to change the access and then assign the VLAN. So more kind of logical steps for you, but for me practice, I just change the access first because I'm not going to put that on VLAN. Right. Show VLAN. Who's that? 1 to 2? Yeah, he's there. 1-on-1. We're good. Class 3 interface range 0310. So it's Blackboard VLAN. Seen a whole lot of them. Class 224. Alright, that's good. Switch mode access. Shot. No shot. Show VLAN. All these guys go to Blackboard. And now set up trunk. So there's only three trunk ports here. So we've got more trunk. Non-negotiable. allowed VLAN. I'm looking something straight to my and remove 999. Alright, I went straight on removing VLAN and I'm gonna spend time. Okay? Show VLAN, then showing trade. This is drop, right? Not VLAN. 1511. 1511, right? Alright, so save. Alright, I'm not going to do too much MAC address table. Go ahead, because of time. A little more than halfway there. Alright, so I'll let you guys do this. In this case, pings, we're going to do, this thing is doing pings. I'll just try to do the ping IPv6 just to get there and then we move on. I'll just copy in this command here. Right, we're getting some ping responses, which is good. Right, 3. It's 23 anyway. 22 is down here. So we still have to do 22, so 22, right? So we cannot ping it. So let me continue going. I'm not going to waste time letting the time out and stuff. So let's continue. That's fine, switch 21. I'm going to configure switch 22 now. Sign VLAN switch ports. Zero 1-2. Shot and show VLAN, make sure we have everything here. Right, search is there, good, moving on. So VLAN now. Right, servers on gig 02. Let's make sure servers gig 02, right? Servers here. Yeah, gig 02 is good. black hole VLANs now. Access. Sorry, support mode access. Right, so these guys are in the black hole. It's good. And if you do a show interface trunk. Did we do trunk? Oh no, we didn't set the trunk port yet, so we're going to set our trunk port. And there's only one trunk port in this case, going gig 01. Negotiate, shut. Sure, VLAN, great. But gig 01 is not there because it went to the trunk. Right, so we still have to do I forgot to take out the allowed VLAN, so I didn't do that. I'll do this. So let's take too long. 0/1. Trunk, right? So it's removed. Not allowed, right? And then we save. Right memory. Right, so let's go back to the ping PC business. 23 wasn't pingable. Technically, it's supposed to work. Alright, there we go. 23 is with ping. 25 is pingable. Yeah, alright. Right, so everybody here is set up as right. All PCs here. Oh, 13, we still have to do 13? Right. No, I don't think so. 13 was last. So let's get 13 done. Yeah. Check there's some errors coming up here. Inconsistent port type. That's because of the VLAN stuff. One port is set as VLAN, the other one is not. As access is sending and he's getting VLAN tagging traffic coming across. Remember, you don't really need to name the VLANs on all the switches. You can just call it VLAN 11 whatever and let it auto name. But for consistency, you'll want to name it. Right, I'll assign VLAN switch ports. Right, constant. All these guys have moved to black hole, and then you have your trunk port. Right, default remain 23, that will be our trunk ports, right? So once we plan it out, so notice these guys get assigned. So we want to make sure our default has nothing here. That's the idea. And you want to make sure that black hole is assigned to something that's not going to be used for anything else. Right, so now we're going to do trunk, and I'm going to move the back to the R, right? And then you're going to do suppose, come on. Hello, VLAN. And we're going to remove 999. To VLAN. Of course, he's gone. Just says, right? 23 is trunk. 23 is trunk port. It's good. 999 is not there. 999 is not there, right? And we save config. Alright, we did a view trunk port. We do MAC address table. View that later. I would like to. Wouldn't I want to? I don't know how much time. Well, we're 2 o'clock already. If you guys want to leave, we'll go ahead and lab. But I'm gonna have to continue and finish this out 64 to 68, and we'll see how far it is. Right? Almost there. Well, I think that's it. Yeah, we're done. Look at that. Into VLAN routing will be either the one after spanning tree. So I did not reach the point of sub-interfaces here. Alright, so let me just go back a bit here. So let me just give you 2 minutes. Go back. Let's do a server 11 ping. Just server 11 ping, because that's supposed to work, right? Server, sorry, yeah, server 11, let me just check. Right. 34 and 35, right? And the router interface, so we deal with that. So this guy, right, this server 11, he comes in. And 2.168.5.45. Ping 21, right? And if we do simulation mode and run the simulation, we'll see what it goes, right? Just coming from this packet. It's simple. Step in across. In this case now, because of the VLANs, it's going to have some tagging. Once it hit the switch, the VLAN, that frame is tagged with a VLAN ID of because of this VLAN ID 5, and it's going to go across this trunk port. That's what's happening here. This other switch is going to pick it up and it's going to send it across the trunk port again. Now, if I were to remove this VLAN on this switch 21, we could try it out and see what happens, right? And see if it really works. It might work. Right, it goes to the other switch, and then it goes all the way down to server 21, and there it is, it reaches there. So it untags and goes to server 21, server 21 on the visor, it gets its packet and everything, and it does its response. Now if I go to 21, and I decide to do no VLAN 5 was the server, right, and it may or may not work, we'll see. Right, so we remove VLAN 5, no ports assigned. Show interface trunk. Right, VLAN's allowed in trunk. Right, so this might work because it's there, right? So we could do that, let's do alright. And if we repeat the thing now, is it? It was working a minute ago. Right? Hit any switch, broadcasting out. Broadcasting out 1 to 21. 21 is the same. Yeah, it receives a frame. What is it going to do? In this, you could actually see the VLAN somewhere here. Hold on. Ethernet. Wait, look at it. I think this is a 5. Oh, I could make a I could be wrong. Hold on. Supposed to have somewhere had the VLAN number in frame. Okay, so right, it didn't work. So let's go back to the time. Go back to our switch 21 and fix back that, right? VLAN 5. Show VLAN. Five is back. They're not gonna give it a name. I'm just gonna show that it's gonna work. So it's there, nothing assigned. And now we come back to our PC and we ping again and see what happens. Okay, there we go. So admin stop worrying for a moment there. Right. The reason why you want to add the VLAN is when I do a show MAC address table, guess what? It's now it is aware of VLAN 5. If it did not have VLAN 5 in this switch, it wouldn't say, well, I'm seeing a VLAN 5, I don't know about it, I'm gonna leave it. It's gonna allow it to come through, right? So that's what's happening there. So if your pass-through switch, pass-through switch is where you want to make sure you have your VLANs along the way. So as you go along, make sure the switches have that VLAN and information of that VLAN. It's a good and a bad thing because guess what? Now it has to have knowledge of the MAC address of that device. So it's passing through, but it has to know it. And look what happened at the end of the day. So that's why you have to put these VLANs through. And yeah, I'll leave you guys to go and do the rest of the things. And that's the end of this this lab. Right? You can check out these links, calculators, the articles for the Blackboard VLAN, and that's the end of this lab. Alright guys, don't forget to save your packet tracer and stuff. And I'll see you guys on Monday. Alright? Monday class. Any questions? Let me know, email. Stuff on the forums if you call me, right? Alright, everybody enjoy the rest of the Saturday, enjoy the rest of the weekend. I'll see you on Monday. Bye.